In 2006, Pluto lost its title as the ninth planet. Overnight, it was reduced to a dwarf planet, a forgotten ice ball drifting at the edge of the solar system. Many assumed it was nothing more than a frozen leftover, a world without significance. But that story is changing. Thanks to new, high-resolution data from the James Webb Space Telescope, Pluto is no longer seen as a silent wasteland. Instead, it is emerging as one of the most fascinating and puzzling objects in the entire solar system. Beneath its icy shell, this little world may be hiding secrets powerful enough to reshape how we think about life in the cosmos. At the center of Pluto's mysteries lies its most famous landmark, Sputnik Planitia, the vast, heart-shaped glacier that dominates its surface. Made mostly of frozen nitrogen, this ice plain is so massive that it shifts Pluto's balance and even affects how the planet spins. But what's beneath it could be far more extraordinary, a hidden ocean of liquid water, sealed below the ice, kept warm by the slow decay of radioactive elements deep in Pluto's rocky core. If true, it means Pluto isn't frozen solid at all. It's alive with hidden motion. And where there is liquid water, the possibility of life always follows. The idea isn't just speculation. Pluto's surface shows clear evidence of activity, fractures, ridges, and strange terrains revealed by NASA's New Horizons spacecraft. These are signs of tectonic restlessness, not a dead world. Add in the gravitational pull of its largest moon, Charon, and Pluto becomes even stranger. The two worlds orbit one another like dance partners, generating tidal stresses that may stir Pluto's ocean from within. But could something be living down there? Some scientists think so. In the crushing darkness beneath the ice, microbial life might exist. Life forms unlike anything on Earth, adapted to extreme pressure, freezing cold, and chemical energy instead of sunlight. Even more unsettling, Webb has detected heat signatures and unusual chemical traces below Pluto's surface. They resemble processes we associate with biology here on Earth, but in this alien world, they could point to something completely different, perhaps even dangerous. Pluto also surprises us with its thin but active atmosphere, rich in nitrogen with hints of methane and carbon monoxide. Ultraviolet sunlight transforms these gases into tholins, complex organic molecules that coat Pluto in a reddish haze. On Earth, such molecules are thought to be stepping stones in the chemistry of life. Then there's Charon. Its surface is scarred with massive chasms, while its poles are painted in strange red patches. Some scientists believe those stains are Pluto's gases freezing onto Charon. If true, it means the two worlds are constantly exchanging material, a cosmic partnership that may extend to their geology, chemistry, and perhaps even biology. Pluto also stands apart in the Kuiper Belt, a distant region filled with frozen relics from the birth of the solar system. Most of those bodies are dead and silent. Pluto, however, is dynamic. It has moving glaciers, shifting ice, and perhaps an ocean that has survived since its violent birth. Born from collisions, warmed by its rocky heart, and still evolving billions of years later, Pluto defies every expectation. The James Webb Space Telescope has revealed much, but it has also deepened the mystery. Did Pluto keep its ocean alive since the dawn of the solar system? Could it possess a hidden magnetic field that shields it from radiation? Are there unknown forces stirring its interior? For decades, Pluto sat in the shadows of the solar system, dismissed as a frozen remnant, too small to be a planet, too far away to matter. But now, thanks to new discoveries, this distant world is forcing scientists to ask profound questions about life, planets, and the hidden stories of our cosmic neighborhood. One thing is certain: Pluto is no longer a forgotten world. Instead, it has become a place of motion, chemistry, and possibly life, a world that demands we rethink the very definition of what makes a planet alive. Beneath its icy crust lies a mystery that could change everything. Pluto's surface already hints at activity. Vast plains of nitrogen ice flow like glaciers, towering mountains of frozen water stand like jagged peaks, and fault lines stretch across the landscape. These are not the marks of a dead planet. They are scars of movement, reshaping, and energy. Something deep within Pluto is keeping it active, even though it lies nearly 6 billion kilometers from the warmth of the Sun. At the heart of this activity may be a hidden ocean. Buried beneath Sputnik Planitia, the giant heart-shaped glacier, is thought to be a sea of liquid water, kept from freezing by heat trapped in Pluto's rocky core. Radioactive elements may still be producing warmth, and the gravitational tug from its giant moon Charon could be stirring the interior further. Together, these forces may keep parts of Pluto alive, despite the extreme cold of the Kuiper belt. If that's true, then Pluto becomes more than just a frozen rock. It becomes a candidate for life. Not life as we know it on Earth, bathed in sunlight and thriving on the surface, but life locked beneath the ice. Microbes feeding on chemical energy, surviving in a dark, high-pressure environment, cut off from the stars. This is where the story becomes even more intriguing. Data from telescopes and spacecraft suggest unusual heat signatures and chemical traces beneath Pluto's crust, patterns that, on Earth, resemble biological processes. They don't prove life exists there, but they remind us that Pluto may not be as lifeless as we once believed. Even its atmosphere raises questions. Thin and fragile, made mostly of nitrogen with traces of methane and carbon monoxide, it glows with a hazy red color. That haze is produced by tholins, complex organic molecules formed when sunlight reacts with atmospheric gases. Tholins are thought to be essential ingredients for the chemistry of life. On Pluto, they coat the surface, fall like snow, and may even play a role in feeding whatever processes are happening beneath the ice. Then there's Charon, Pluto's giant moon. Unlike most moons, Charon doesn't simply orbit Pluto. Instead, Pluto and Charon orbit a point in space between them, locked together in a cosmic dance. This unusual relationship generates tidal forces that may help keep Pluto's suspected ocean from freezing. And Charon itself carries mysteries, vast canyons, red polar caps, and signs of its own past activity. The two worlds seem to be connected in ways we don't yet understand, exchanging material, energy, and perhaps even shaping one another's evolution. But here's the larger question. If Pluto is active, then what about the countless other icy worlds beyond Neptune? The Kuiper belt is filled with objects that have barely been explored. Could some of them also hide oceans, heat, and even biology? Pluto might not be an exception. It could be the first example of a much bigger truth. This changes our perspective on life in the universe. For years, we thought the outer solar system was too cold, too distant, and too harsh for anything to survive. But if a world as small as Pluto can maintain liquid water and chemistry, then maybe life can exist in places we never imagined, beneath ice, in hidden oceans, shielded from the stars. And that leads us to a deeper reflection. Pluto reminds us that size does not determine importance. A tiny dwarf planet on the edge of the solar system can still challenge our understanding of biology, geology, and the origins of life itself. So now, the question isn't only could Pluto support life? But what kind of life might it already hold? If microbial organisms exist beneath its icy shell, they may have evolved for billions of years, adapting to conditions utterly unlike our own. Finding even the simplest form of life there would revolutionize science. It would prove that life doesn't require Earth-like conditions. It can arise wherever energy and water exist, even in the frozen twilight of the Kuiper belt.